Hello, today we're going to find out a little bit more about the properties of metals, particularly relating to how they're bonded together, but also we're going to throw something called alloys in as well. So a starter for you today is to work out which of these are elements. You will know if it's an element if it's on the periodic table. So if you're not sure, search for it on the periodic table, and if it's not there, then it's not an element. So what you need to find this out for is iron, tin, steel, brass, copper, and bronze. Pause the video now and make a list of the ones that are elements and the ones that are not elements. Okay, so hopefully you will have written down that tin, copper, and iron are all elements. You know that because they're on the periodic table. But then steel, bronze, and brass are not elements. Now, I know that you've probably heard of these three things before. They're all metals, and you've probably used them in your day-to-day life. However, we may not have thought that much about what they are actually made of. Now, these three things are alloys, which means that they are a mixture. So an alloy is actually a mixture of a metal element with one or more other element. And the next slide is going to tell you exactly what they are made of. It would be worth your while pausing the video now though, just so that you can write down the definition of what an alloy is before you move on. So this is what those three alloys are made of. So bronze is often used for making things like statues, and it's made of copper and tin mixed together. Brass is often used for making things like musical instruments because it's quite sonorous as well, another one of the properties of metals. And that is made of copper, but instead this time the copper is mixed with zinc instead of tin. And steel is often used to make things like cutlery. It's also used a lot in construction, and it's made of iron mixed with carbon. Now, carbon is actually not even a metal element at all. It's a non-metal element, but it's still used to make alloys. So the next slide is going to have a few questions on about these elements or these alloys. So feel free to come back to this one if you want to refer back to it. So a few questions for you. Number one, what is the difference in the compositions, that means the makeup of brass and bronze? How are they different? Number two, this is a suggest question. So I'm not expecting you to know the exact answer, but I'm expecting you to make your best guess at this answer. So suggest some advantages of using steel rather than iron. Why do we think that might be better? And then number three, a statement for you. Alloys never contain non-metals. Can you explain, please, whether you think this statement is true or false? Pause the video, answer the questions. Okay, so your answers are: number one, the difference in the compositions of brass and bronze is that brass is made of copper and zinc, whereas bronze is made of copper but mixed with tin instead of zinc. So that's the difference between those two. Number two, suggest some advantages of using steel. So a couple of advantages that you may have said is, number one, that steel is harder than iron. So that means it's more difficult to sort of dent it. And number two, steel doesn't rust or corrode as easily as iron does. You can imagine if you made your cutlery out of iron, you put it through the dishwasher a few times, it's going to get rusty pretty quickly, whereas steel cutlery doesn't do that. Okay, and number three, alloys never contain non-metals. This statement is false. We know this because in the table previously, it showed that steel is an alloy, but that's got carbon in it, and carbon's a non-metal. So actually, alloys sometimes can contain non-metals. The definition, if we go back to that, says that alloys are a mixture of a metal with one or more other element. That other element doesn't necessarily have to be another metal. It could potentially be a non-metal, like it is in steel. Okay, so a little bit more about the bonding now. The difference between the bonding in a pure metal and an alloy, the main difference is this. In a pure metal, we can see that the metal ions are nicely lined up in neat rows. And what this means is that in a pure metal, they're malleable, they're ductile. That means that the layers of atoms in them can slide easily over each other. So if you were to hit it with a hammer, for example, you would be able to change its shape. Whereas with an alloy, let's say you've got copper and tin mixed together. The sizes of the atoms, copper and tin, are slightly different, and that's going to mess up your nice, neat rows of ions, because actually, if one of them is smaller than the other, you're going to end up with these small little ions mixed in here, and it's going to mean that if you hit this with a hammer, it's going to be more brittle, it's not going to be as malleable, it's not going to change shape as easily, because those neat lines, which are in a pure metal, are not there. They've been disrupted, they've been distorted by the addition of whatever the metal has been mixed with. So a couple of questions related to this are, number 4, could you explain in terms of its structure why copper metal, and you can assume that this copper is pure copper metal, why can that be extruded into wires? The other name for that is being ductile. Number 5, can you explain why copper, and assume that this is pure copper again, why can copper conduct electricity? And then number 6, sterling silver contains 92.5% silver, and the rest is actually made up of copper. So part A, can you explain which of those would be more malleable? And part B, could you try to calculate, so this means you might need to get your calculator, calculate the mass of copper in 1 gram of sterling silver. Pause the video now and write up your answers. Okay, so answers are, number 4, in copper, the layers of ions can slide over each other, which means that it can be extruded into wires, because copper is a pure metal. Number 5, copper can conduct electricity because it's got those delocalized electrons which can move throughout the structure. If you don't remember about delocalized electrons, go back to the previous lesson and remind yourself about the delocalized electrons. And finally, number 6. 6A, the one which would be more malleable is pure silver, because the copper in sterling silver would distort the layers, and it would mean that those layers wouldn't be able to slide over each other like they can in the pure silver. And finally, part B, the mass of copper in a gram of sterling silver is 0.075 grams. If you aren't sure how I got that number, what I did was I got 100, because that would be the full amount of percentage that a percent is out of. 100, take away 92.5, remember that's the percentage given to you in the question. That gives you 7.5 grams of copper if you had 100 grams of sterling silver. But you haven't got 100 grams of sterling silver, you've only got 1 gram. So what you would then need to do is get that number 7.5 and divide it by 100, and that's going to give you 0.075 grams. That's the amount of copper that would be in 1 gram of sterling silver. Okay, that's it for today. I will see you again sometime soon.